Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. We are still in section 4.4, and this is the last type of indeterminate forms, indeterminate powers, 0 to the power 0, infinity to the power 0, 1 to the power infinity. Here we will have f of x function raised to a function, so function to a function. And if we have these forms, limit of f of x is 0 and g of x is 0, so we get 0 to the power 0, or infinity to the power 0, or 1 to the power infinity, then these are indeterminate forms. And to solve or to find the limit, we cannot use L'Hopital's rule, of course, directly. We have first to do something, and what we need is to bring g of x down to the right in front of f of x, and we can do that if we call this function f of x to the power g of x y, and then take len of both sides. Then we can bring g of x here, and then len y would be g of x len f of x. There is also another way to deal with it. We write it e to the power len f of x to the power g of x, and then we bring g of x to the right here in front of ln f of x. Now once we do that, we will get type 0 times infinity, and then we can change it to infinity over infinity or 0 over 0, and we use L'Hopital's rule. And note that 0 to the power infinity is not indeterminate form. Okay, 0 to the power infinity is not indeterminate, it is 0. But these three are indeterminate forms. So if I replace x by 0, sine 0 is 0, 1 plus 0 is 1, 1 to the power cotan 0. Cotan is cosine over sine, 1 over 0 is infinity. So this is in the form 1 to infinity, and this is an indeterminate form. So what to do? I call y equals 1 plus sine 4x to the power cotan x. And then we apply len to both sides. And then using the properties of the logarithmic functions, I can bring cotan x here in front of the len. And now I find the limit of lny when x approaches 0 from the right. And after I find the limit of lny, after I get the answer, I'll find the limit of y. And y is the function we need to find its limits. So limit len y would be limit this function cotan x times len 1 plus sine 4x. And cotan 0 is cosine over sine, 1 over 0, that's infinity. And this is 0, len 1 is 0, so we have 0 times infinity. You remember in this type, infinity times 0, what to do? There is a special video about that if you want. So we write it len 1 plus sine 4x over, we try to write one of the functions down. And this is cotan x. And I know that cotan x is 1 over tan x. So immediately I can bring it down as tan x. And now if I replace x by 0, I will have 0 over 0. Tan 0 is 0 and len 1 is 0. So now I can use L'Hopital's formula. The derivative of len is 1 over 1 plus sine 4x times the derivative of 1 plus sine 4x, which is derivative of sine 4x is cosine 4x times 4 all of this over the derivative of tan x, which is secant square x. I need to simplify a little. So I have, this is secant square x. I can bring it up as cosine square because 1 over secant is cosine. So I will write it 4 cosine 4x over 1 plus sine 4x times cosine square x. And now if I replace x by 0, cosine 0 is 1. So I will have 4 times 1 times cosine 0 is also 1. Sine 0 is 0. So the answer is 4. So ln y goes to 4 as x approaches 0 from the right. So I need y, not ln y. So if I raise both sides to the base e, then e cancels ln and y goes to e to the power 4. So the limit of y when x approaches 0 from the right is e to the power 4, and that's the answer. And this is y. 0 to the power 0. Indeterminate form. Let y equals x to the power x. Len y would be len x to the power x. And this would be x len x. Let us find limit len y. It would be limit x len x 0. Len 0 is negative infinity, so it's 0 times infinity. Bring x down as 1 over x. Now I have infinity, negative infinity over infinity. So I can use L'Hopital's rule. Derivative of ln x is 1 over x. And derivative of 1 over x is negative 1 over x squared. Simplifying this, it would be negative x squared over x, or just negative x. So the answer is 0. So ln y goes to 0, means y goes to e to the power 0, which is 1. So if this is y, then limit y when x approaches 0 from the right is 1. 0 to the power 0. Indeterminate. This is y, and apply ln to both sides. Find limit ln y when x approaches 0 from the right. Zero times negative infinity. I bring square root of x below. Now it is infinity over infinity. I can use L'Hopital's rule. This is 1 over x, and derivative of 1 over u is negative 1 over u squared times the derivative of the square root of x. Okay, I use the formula. Derivative of 1 over u is negative 1 over u squared times u prime. So this is u squared and this is u prime. Let me simplify this. So I have 1 over x divided by or multiplied by x over, well, I can I can even do it. First, let me write it as 1 over x, and this is negative 1 over 2x square root of x. So x cancels with x, and I'll have negative 2 square root of x. So in fact, this is negative 2 square root of x. When you replace x by 0, you get 0. So len y goes to 0. Hence y goes to e to the power 0, which is 1. So limit x to the power square root of x when x approaches 0 from the right is 1. 1 minus 0 is 1. 1 over 0 is infinity. So immediately I call y. So any of these three forms, you immediately deal with this method. So len y would be 1 over x len 1 minus 2x. And now I find limit len 1 minus 2x over x. 0 over 0. I can use L'Hopital's. 1 over 1 minus 2x. The derivative of 1 minus 2x is negative 2 over 1 because the derivative of x is 1. Now if x is 0, the answer is negative 2 over 1. So len y goes to negative 2. This means y goes to e to the power negative 2. So limit y when x approaches 0 is 1 over e square or e to the power negative 2. 1 minus 1 is 0. 1 over 0 is infinity. Now let us take limit len x over 1 minus x when x approaches 1. Len 1 is 0. 1 minus 1 is 0. So it is 0 over 0. I can use L'Hopital's. Derivative of len x is 1 over x, and derivative of 1 minus x is negative 1. Negative 1 over 1, that's negative 1. Len y goes to negative 1, then y goes to e to the power negative 1, and limit y when x approaches 1 from the right is 1 over e or e to the power negative 1. E to the power infinity is infinity plus infinity, so infinity 1 over infinity is 0. This is the form infinity to the power 0, indeterminate form. I take len of both sides. 1 over x would be here. Now I find limit len ex plus 10x times 1 over x or just over x. Now I have infinity, len infinity is infinity over infinity, so I can use L'Hopital's. Derivative of x is 1. That's good. Derivative of len is ex plus 10x, and the derivative is ex plus 10. Infinity over infinity. Use L'Hopital's again. Ex over ex plus 10. Infinity over infinity. Use L'Hopital's again. Now e to the power x over e to the power x is just 1. So ln y goes to 1. Y goes to e to the power 1. So limit y when x goes to infinity is e. Cosine 0 is 1. 1 over 0 is infinity. X squared 1 over x squared ln cosine x. Let us find limit ln cosine x over x squared. X goes to the power, x goes to 0. Cosine 0 is 1, ln 1 is 0 over 0. Use L'Hopital's. Derivative of ln cosine is 1 over cosine times derivative of cosine over 2x. So let me write this as tan x over 2x. Tan 0 is 0 over 0. Use L'Hopital's once more. Derivative of tan is secant square x. Derivative of 2x is 2. Secant 0 is 1. So ln y goes to half. This means y goes to e to the power half. So limit y when x approaches 0 is e to the power half. And that's the end of the section. Hopefully you are good now with L'Hopital's rule.